Hello, and welcome to today's episode of Rawkode Live. Before we get started, I want to take a little bit of time just to say thank you to Equinix Metal. Equinix Metal is my employer, and they donate the time and resources that I need to put this show together. So thank you very much, Equinix Metal. Equinix Metal is a bare metal cloud, and we are offering you $50 in credit so you can try it out yourself. The code is rawkode-live. This will allow you to spin up our smallest instance for up to 100 hours, but of course it's much more fun to play with the larger instances and take advantage of those NVMe disks, up to 400 gig of RAM, and crazy CPUs. So use the money wisely or unwisely, depending on how you're feeling. If you want to chat about anything that we talk about in today's episode or any other episodes, we do have a Discord server. Feel free to join us and keep the conversation going. Very useful if you're not watching live. Please remember to subscribe to the channel and thumbs up the video if you can and you enjoy it. This just helps other people discover the content too. Today we are doing part 2 of the Cilium episode. Last time we had a few problems which we've now corrected, fixed, and we're going to explore Cilium and see how it can make our lives better. And for that I am joined once again by Ilya. Hello, Ilya.
Hello, David. How are you doing?
I'm very well, thank you. I'm excited. I want to, properly kick the tires on Cilium this time and see what I can do for my Kubernetes CNI.
Yeah, I'm glad to have it working now. It's just a few things, I think. At the end of the day, we have a few extra parameters and it's working. The thing about it was that we are basically bringing it up in a new environment that hadn't been tested before. Right?
Exactly. Yeah. I mean, bare metal is not as simple as other environments. There's a little extra bit of tweaking that needs to be done, but we've got that working. I think it would be really cool if we just start and talk about the news that I seen dropping on Twitter yesterday.
Oh yeah, of course.
So let me do. Oh no.
Yeah.
That one.
Yes.
There we go.
Yeah, IceBerlin has raised 29 million in funding from various investors. This is Series A, and we are launching our enterprise offering as well. If you could show the website, the next tab there. Yeah. So if you go to iceberlin.com, you can find out about Cilium Enterprise and how it differs from Cilium Open Source. You can also see some of our customers and read about the team and find out any job openings that we might have, and we do have a few.
Yeah, we kind of timed these 2 episodes serendipitously well, I guess. And the last time was just after Google made their announcement about Cilium on GKE, and then randomly yesterday the news dropped about the Series A, and I was like, wow, really cool.
A good timing.
Yeah. Okay. Yeah. So yeah, Cilium Enterprise. I mean, we're going to be playing with open source today, but maybe you want to just give a quick pitch about what it.
Mostly, Cilium Enterprise offers additional features for enterprise security teams, effectively enabling flow logging to systems like Splunk, and a few other features that are summarized on the product page. So if you click on the top navigation product. So just at the bottom there's a long summary of the enterprise features. If you just keep scrolling. So, like for example here, so in terms of core functionality, it's all the same. Then as you get into other functionality, Cilium Enterprise has additional support for third-party BGP integrations. And in some of the other sections, you will see that there are exclusive enterprise features. Yeah. Like here, for example. Yeah.
All right. So today, let's cover where we are. So I like to do very little upfront on this show. But we do need a Kubernetes cluster.
Yeah.
And assuming nothing is broken since I spun this up, good. We are currently in a position where I've used Cluster API. We only have 1 control plane node, and all the worker nodes are currently not ready. That's because they won't be considered ready until we deploy Cilium and there's networking in our cluster. One thing I did different from last time is I think this may be useful to other people. So this code now is all available on gitlab.com. I really need to stop the tab suspender, shouldn't I? gitlab.com/rawkode/equinix-metal-examples. There's a Cilium directory with the cluster API code and the Cilium configuration, so people can check that out and run it themselves. I'm just using Helm template, which is spitting out the Cilium.yaml here. So step one for us, we're just going to get this applied to the cluster. We're going to run the connectivity checks. This is stuff that we did last time, only this time it's going to work, he says confidently. So let's get Cilium on this cluster.
1, 2, 3.
Oh, it helps if I create the namespace.
I think that would help.
All right, there we go. So let's just keep an eye on that for now. We have a little watch.
Did you say you could also use resource sets for this, or that turned out to be tricky?
Oh yeah, so you definitely can use cluster resource sets. I just didn't use them here because it would automatically deployed it to our cluster, and I wanted to do the apply live. I should use the right namespace.
Sure. Yeah.
You're supposed to be keeping me right here. Come on. Right. There we go.
Okay, that's happening.
Yeah, so that's happening. So we could have used cluster resource sets, and I will actually put an example of that up tomorrow, because Jason and I are taking over the CNCF Twitch channel doing
cool.
API stuff, at least for an hour anyway. So the code from that will be also in the repository. Now it looks like it's happy.
Oh, great! Yeah.
So now we can apply. In fact, I added a just target for this, and that is just deploying.
Yeah.
This.
So is that your just file, and like, I mean, does it support a subset of make syntax?
Yeah. So I generally try and use make files whenever possible, but there are some really cool semantics in just that just you can't really do. Like, specifying inline bash scripts is really cool, which means I can pick an interpreter, because when I tried to do this with raw make, read and echo uses the built-ins of bash. And I know I could have changed the shell and make, but sometimes it's just nicer to use just file. So it's a cool tool. Okay, so we want to confirm that those tests are happy. So no restarts, all running. This is what we expect, right? This to you is a healthy running Cilium install.
Yeah, looks great. Yeah. All of them are happy, as in ready. Yeah.
There you go. 9 minutes in, and we've already made a lot more progress.
Nice.
Okay. Now let's just delete all those resources. I didn't add a just target for that. I really should have.
Yeah.
And they're gone. Okay. So let's pop over to the docs. Boom, boom, boom. Now, the last time we did this episode, we started to talk about the Star Wars example. Is that where you want to start today? Or yeah. Okay.
Yeah.
That means I'm going to have to remember where that lived.
Yeah, I think
it was network policy.
Oh, maybe yeah. That's right. It should be there. Yeah.
No, I think I was wrong. Let's try.
Yeah, again started, and then
I'll find it. I'll remember. There we go. It was this, wasn't it?
Yeah.
Yeah, deploy the demo application. So this is a Star Wars inspired example. It has 3 microservices, a Death Star, a TIE Fighter, and the X-Wing. Okay, so if I just copy the first line, and then we can talk about what that's actually deployed. There we go. And before I go deploying things to my local cluster, I should just make sure that I don't accidentally do that. Okay, so off it goes. Okay. I like it when things work. So it just wants me to pull out the pods and the SVC, so we'll just make sure that all that looks good. We got a DevStar service, excellent. And this wants me to list. Yeah, I don't understand why is it asking me to do this? Oh, we're trying to confirm the endpoints, right?
Oh, yeah, that's right. And we're using Cilium.
And I'm using a different namespace.
Yeah,
So
okay, no.
yep, so that lists my Ciliums, and then we'll just do the endpoint list.
Yeah.
Oh, I need to pick a pod. Okay.
Okay.
All right. Do you want to walk us through that? Because I have no idea what that just did.
Yeah, of course. So this shows us. No, hold on a sec. So this is for the Star Wars demo, yeah. So it just shows us the kind of underlying representation of these demo pods in inside of Cilium. There's also a CRD that's supposed to represent the same, but essentially what it is about is that Cilium allocates an ID of its own for these apps. Yeah,
right.
so
I'm trying to just
you get the
clean
same
up.
information if you also run kubectl get CEP.
Okay. Is it namespaced or is it cluster scoped?
Would be namespaced.
All right. So get CP.
Right. So this is effectively the same. What do you call it? The same object that's represented as CID.
So when we talk about a Cilium endpoint, we're just talking about some networked target, some pod inside of our cluster. Okay.
Yeah.
And we can see here that we've got our 2 DevStar pods that we deployed. They've got identity, they've got IPv4 addresses, they've got some sort of state. I'm not sure what that means. So this just means that Cilium is aware that these pods have an IP address and are endpoints that could be requested.
That's right.
Right.
Yeah.
Okay.
Yeah.
Now, well, let's see what the tutorial tells us to do next, and then
Yeah.
I can throw questions at you.
Yeah. Yeah, the tutorial just highlights that Cilium allocates an identity, which can be seen in that identity column.
Okay, and just because I've seen it on that list there, like we've got enforcement disabled, so I guess this is like there are no network policies being applied to any of these endpoints at the moment.
That's right.
Right. Okay. Cool. All right. So now it's telling us that we want to check for access. So, all right. So, assuming this wants us to have the X-Wing service blow up the Death Star.
Yeah. Okay. Yeah.
Yeah, that's a cool example. Okay, so let's grab copy first line. Oh, there we go. Eventually I'll stop doing that. So we're going to exec into the X-Wing. We issue a curl request.
Yeah.
And it's sending it to the Death Star service. And we're just requesting landing. And we get ship landed. Okay. Making sense so far. Next, it wants us... okay, so now the TIE fighter wants to request a landing. So let's just... Okay, got it.
Cool.
So we want to try and protect the Death Star, and we're going to do that through applying policies. All right, I'll copy and paste this, and then maybe we'll just quickly run.
There's a command down below, I think, that just... That would do the same.
I'm going to do that so many times. Okay.
Yeah.
So this is our network policy.yaml. Let's get some syntax highlighting going on here.
Yeah.
And we have some rule, and this is an L3, L4 policy to restrict the Death Star access to Empire ships only. Okay. So when we're applying this rule, describing this rule, we need to have an endpoint selector, and we're just saying whenever the organization is Empire and the class is Death Star, that we are going to allow ingress from Empire organization ships, and we can even restrict the ports that we allow them to access. Okay. So, does it just want me to apply this?
Yeah, that's right. Yeah.
It does. Okay, cool. So apply network policy. Done. Easy. So that means that the TIE fighter should still be able to request a landing, and our X-wing should our X-wing should fail. So let's try a TIE fighter first. All right, we can land that ship all day. And our X-wing.
Nope.
Awesome. It's just going to time out, right?
Yeah.
Well, we don't need to wait for that to time out. So nice. Okay. So that was pretty painless.
Yeah. So yeah, and this is so what we've done is created a Cilium network policy object that specifies these rules using Cilium's own policy syntax, if you like. Cilium also supports the traditional Kubernetes network policies, which have less features to them, right? So some of the things that we will probably see soon, if you keep scrolling through this tutorial, I believe we should have an L7 policy down below, which is something that you can't do with the traditional network policies in Kubernetes. So let's just go step by step.
Okay, so we applied the LV-L4 policy. All right, so let's run that endpoint list again.
Yeah, you could probably use kubectl get CEP. Or this one. So we can see that policy is being enforced, right?
Did I run the wrong command?
From here, disabled. This should be enabled for something. The output is a bit funky here, to be honest.
Yeah, let me. I mean, I can make it smaller.
I think you know what it is, David.
Well,
I think because actually this Cilium endpoint list will only show the endpoints for the given node. Because this tutorial was assuming Minikube.
Right.
This command would have worked, but yeah, if you do get CEP, that will show you a better version. So now endpoint state, the policy enforcement is actually not shown here, right? Or am I missing? Yeah,
no, I don't see it. So I'm going to find the worker with the Death Stars on
Sure.
it. That's where the policies will be, right? So
yeah, that's right. That's where the endpoint will be for that.
Which means we want to filter the namespace on Cilium, and I just want to see what the one is with the 4G SML, and then run the endpoint list again against that Cilium, which is VW.
Yeah, that's right. So
there we go. So we have enforcement enabled here.
Yeah, that's right. So can you do Cilium endpoint list -- help? Complete debug host. Okay, right. Yeah. So this is just local to the host. I'll have to have a look into why this ARG doesn't present this. Maybe it is actually shown. Yeah, actually, if you do scroll back up where the get CEP output was, okay. So it's for the Death Star that that's the Death Star that we want to see, right? So if you just do a kubectl get YAML on one of those, that's Death Star endpoints.
zoom this back in. So this is describing one of those.
Okay, so
it's quite big.
maybe you could do a describe on this. Yeah, actually, describe doesn't show that stuff. So
okay, so describe Death Star. Let's pick the first one. Right, so we can avoid the managed fields. Yeah, I don't see anything about enforcement here.
Okay, so I got something for me to take a look into. Because
but
in
we did test it. We've seen it working.
Yeah, we can see it working in the.
If I take off this, we see it on the node one, right? So the enforcement is enabled. So cool. So let's carry on. In fact, it's telling me to do get CMP. Let's take a look at that. We have, oh, that's just our rule one. Okay.
That's right. That's the one we've created.
And then it wants me to describe it. So is everything that we do with Cilium, I mean, does it always expose these custom resources? It's just the way it works, right? Everything is that way.
Yeah, that's right. Yeah.
Okay.
Yeah, and as I said, there's support for the traditional Kubernetes network policies, which are inbuilt, but these Cilium custom resources are obviously encouraged. They have more features.
Nice. So can we? What's the difference between an L3 and an L7 policy then?
Oh yeah. So L3 and L4 policies are implemented in eBPF and effectively enforced at the kernel level, while L7 policies are implemented with Envoy and custom filters that we have for Envoy. So effectively, when you do define an L7 policy, Cilium will spin up an instance of Envoy that will implement that policy, and Envoy will be attached to the. So that it'd be like a, in Envoy would be transparently attached to the pod, in effect.
Okay.
Yeah, we can dig into that if you like, but maybe we could define the policy first. So this demonstrates how that policy would work.
Okay, so let's run this. So this is another curl command from the TIE Fighter, and
boom,
we blew up the Death Star. Okay, so we don't want that to happen.
Right.
So we want to define an L7 policy. So this is like L7 just means that it's protocol aware, so it actually understands HTTP, right? Okay.
That's right. Yeah, exactly. So this is just an amendment to the previous policy, I believe. So it's using the same name, so you just want to have a new object.
Okay, so we've got the same selectors, only this time. Yeah, so we can now add this and say, hey, we don't.
Try. Yeah.
Is this allowing? So yeah, ingress, supports.
Yeah, of course.
Rule. Okay.
Yeah.
Let's reapply. And then back to this. Okay, and now if we do request landed.
That'll work.
And if we try the exhaust port, we get access denied.
Yeah. So yeah, I mean, I don't know. Do you want to dig into how it works? Take a look at the Envoy process. I mean, confirm that there is one now, or something like that.
I don't understand if I'm being really silly.
Yeah.
Oh, no, right. Okay, this is the request line. Okay, so we're only explicitly allowing access to the request landing. Yeah, it's not that we're blocking access to the exhaust port. We're only allowing this. Okay. Yeah. Would that be possible? Can we say allow everything except for this endpoint?
I wonder actually. So yeah, I think you could use regexes actually. Yeah, so you could have regex for the method or regex for the path.
Okay,
For example.
cool.
Yeah.
Okay, so do you want to dig into this a little bit then? And
Sure, why not? Yeah.
So what's
Yeah.
so
So
where is Envoy?
yeah. So let's have a quick look at that. So if you go back into that pod where you've Cilium pod where you ran Cilium endpoint list earlier.
You want me to go inside the pod?
Yeah, or you just like replace Cilium endpoint list with PS.
Can you say that again?
Replace PS minus AF or something like that.
PS.
Not
without the Cilium, right?
yeah, no. Okay. Maybe it's not AF. Well, just ls proc, for example. Okay, right. Yeah, no, you can see it now. So if you ls proc /668, and take a look at argument, for example. Yeah.
Oh, it's command line, isn't it? Oh.
Yeah, exactly. So,
okay.
so you can see that there's Cilium envoy binary that has the these arguments. There is a file in var run Cilium bootstrap pb, and it's logging somewhere. We'll be logging back to the Cilium log, I guess. Yeah, but what you can see is that there is now an envoy process inside the Cilium pod that is.
Okay, so when I deploy
this policy,
Cilium to my cluster, right, we have an agent on every single node, and that agent is running the Cilium agent, Cilium health. That's I think that's been cut off. I'm not sure what health R is, but and an envoy or envoy. I'm going to change the way I say that every 10 minutes. I think it runs an envoy as well on all the nodes. So the agent is doing like what the health checks and the rules and the enforcement at the L3 and 4 level, but all the L7 stuff has been proxied by envoy, and that's being configured
by the agent.
Okay, nice. Okay, that makes sense. I get it. Like, very cool. And I guess is that just a vanilla envoy? I can use all of the different features of envoy through the proxies here. Like,
no. Well, I mean, you could do some things there. I can't. I'm actually not sure myself, but it is definitely not a vanilla version of Envoy as we build it ourselves with some custom filters, because we have to have some C++ based filters that have to be built at build time. But other than that, it's not like a fork or anything. Right? We build an upstream plus add our filters to it.
Well, it turns out, I think the next part of the tutorial was actually my thinking anyway, when I was like, well, I don't want to explicitly allow a single path. I really just want to block the exhaust port. And I think this is kind of what it's saying here. Is like, hey, we can match the exact URL, or we can use some regex. So
yeah.
We've also already described the network policy. We've kind of seen that. Okay, so let's try this. So we can also do all of this with the Cilium CLI as well. So this is saying I can run Cilium policy get. Cool.
Yeah.
Right, and that's just the same row. Perfect.
Yeah, exactly. Yeah.
All right, what do you go next? All right, and now it wants Cilium monitor.
Yeah, but perhaps. Yeah, well, let's have a look at Cilium monitor first. Yeah.
I'm gonna have to.
And if you now make a request to it.
Yep. So let's try exhaust port. Oh yeah. And we can actually see that being done now. Okay, so the monitor just gives me kind of visibility into how the network policies are enforced, I guess. If I do request landing, yep, that was allowed. Oh no, that was denied.
Mm-hmm.
Did I get the thing?
Request landing post.
Oh no, because it has to be a post that allows. Okay.
Yeah, this one.
Just keeping you on your toes. There we go. Ship landed. Okay, and we get.
Yeah.
Okay, cool. That's really cool. I like that.
Yeah. So if you now have a look at Hubble UI, we should actually see some of the same information there.
Okay, so
Cilium monitor was the like the predecessor to Hubble, if you like.
Okay, so we have two pods deployed here, Hubble Relay and Hubble UI. These were enabled in the Helm, so just global Hubble Relay, blah, blah, blah. And that's deployed a UI. So if I do service, port forward, SEC, Hubble UI, and that's just port 80. And that gives us...
Yeah. So if you try and select the namespace where those, whether the Death Star and friends are, you should be able to observe, for example, like try and make a request from the X-wing to the, try and destroy the Death Star from the X-wing. You should see those policy denials in the log below.
Okay, let's do that then. Oh. There we go. So that's our landed. So let's try and hit that exhaust port again. That was the 9.
And from X-wing as well.
Oh, from X-wing. Should we be seeing something here?
I think not for HTTP because that hasn't been enabled. There are additional options that we need to do for that. But if you do this,
okay, right. So the Hubble UI.
Yeah. So now these packets are being dropped. We should see these here. Try and update. We're not seeing it. Okay. How about we take a look at the policies first? Anyway, we should see our policy here in the UI. So this is the policy that we've specified.
Yep.
And if you go back to flows, it's not showing it here.
So this should be showing traffic that it's blocked.
Yeah, that's the purpose. Well, did you?
Have I forgot to enable something?
Maybe, I don't know. Did we debug this last time? Didn't we offline?
We did, didn't we? Because the last time I deployed this, but I think I was missing relay last time, whereas we definitely have relay now.
Have a look at the relay log, for example.
Yeah, sure. Hubble. Really? Okay. All complete, not plain.
Yeah.
Oh, because I can't spell Cilium.
Yeah.
Logs F Hubble relay. There we go.
Yeah. Okay. So yeah, looks like this is still not connecting back to the Hubble port. Yeah, I think there was a remember we had to enable that port 4224 or 244.
Yes.
I'll find the Slack message I sent you. Yeah.
Yeah, that's ringing a bell. Actually, there was something with that port. I can't remember what I did.
So Well, I think you could do you can do is edit the Cilium config map now.
Yeah, let's do it. Config map Cilium. Oh no, I keep doing that. Edit config map Cilium. Okay.
And have a look for Hubble. Enable Hubble, and what else is there? Hubble listen address. That one.
Ah, yeah. It's all coming back to me.
Yeah, right. So column 4244, I believe, right?
Ah, yeah, right, okay.
All right.
So if I just kick Hubble now, right?
Cilium.
Should I just kick everything?
Just the Cilium agent pods, just the allocates up.
Okay, so the pods case app equals Cilium. All right, so I should remember to add something here. So expose listen address. I'll do that before I push this code up. And we run get pods. We've got Cilium happy again. And if I hit logs on Hubble.
Might take a little moment.
Okay, let's see if we can get exhaust port. I'll need to restart Hubble, surely, right?
No, I think it's retrying, right? So if you look at Hubble relay log again, you see now it's connected. No, yeah. So I think now it's actually trying to do something. I think it's doing something that looks just about right. If you reload this once again.
Oh.
Yeah, there you go. So you can see the drop packet over there.
Yeah, okay, so...
Oh, right, okay, yeah, because I was worried that I missed something.
I'm always worried, don't worry about it.
Surely, surely this wasn't an enterprise feature.
Awesome, so Hubble...
Yeah.
Okay, there's quite a lot going on here. I just want to make sure I understand this. So Hubble is a UI. Right away, we can see that spaceships speak to the Death Star on port 80 HTTP. The Death Star has no egress. This spaceship, I'm assuming that's just because I used one of the pods. Yeah, this is the X-Wing class spaceship, whereas we also have a class TIE Fighter spaceship. I'm just going to run that as well. Let's do... exhaust port will be denied, but we do have request landing. And... should I just refresh this? Maybe that will rebuild it. Oh, there we go. Nice.
Oh, yeah.
Very cool. So I can kind of, at a nice high level, just really visualize the traffic here.
Yeah.
I love that it's even just showing me this, the actual endpoint that was last hit. We got a 200. Really cool tool for debugging our network. I can see, all the times we have problems in my cluster.
Yeah. So, and the reason you see the HTTP, as I mentioned, to enable full visibility of HTTP, you need to add a few extra options, which are not enabled by default. But you can see when because we have the Envoy proxy running, we can actually Cilium intercepts those HTTP sessions already, so we can see the status codes here.
Yeah, I'm assuming there must be other traffic going on here too, right?
Possibly.
Does it monitor itself? Yeah, it does. There we go.
Yeah, of course. Yeah.
Right, really cool tool, and I'm glad it's not enterprise only, so I can use it.
Right. Yeah. So in the enterprise version, you have additional features around export and additional filters and various other things. We can do a session on that later on if you like as well.
Yeah, definitely. So I think that's the end of the TIE Fighter thing. What other features is Cilium bringing to the table that we could maybe explore? Is there anything else we should cover here?
Well, I guess one thing that you could cover later, but that will require changes in config, is kube-proxy replacement. So Cilium has a more performant load balancer that you can use instead of kube-proxy. It's implemented in eBPF, of course, and it doesn't use IP tables, which have scalability and performance issues.
Yes, I have definitely run into those problems in the past in a former life. So that means that when I spin up my Kubernetes cluster, I can say, okay, don't deploy kube-proxy, and then what does Cilium do then? How do I?
So so I mean, there are a few ways to do it. You can deploy it into an existing cluster, and also you can now basically enable a few options in Cilium and delete kube-proxy. Right. You can do that perhaps if you feel brave today. The other option is, of course, to not even deploy kube-proxy in the first place. But I'm not actually sure whether in Cluster API you have an option for that.
Unfortunately, Cluster API doesn't allow us to integrate with the skip phases section yet. I know that there's some ongoing work to make that happen, but not yet. But we can always just nuke the kube-proxy. I mean, it's just deployed as a static manifest anyway, I think. So we can always.
That's right. Yeah. So there is a guide for this that you'll.
In fact, here it's just like here, delete this daemon set. It's fine.
Yeah, and in the 1.9 release, we have a few new cool features. Actually, if you want to pull up the blog, Cilium.io blog, there's the 1.9 blog post. Today we used 1.8 as 1.9 came out just yesterday, and we haven't updated all the flags in your configs there, David. But the 1.9 comes with maglev support, which enables consistent hashing inside the load balancer effectively. So you could hit the same pod if you like.
Okay, cool. Well, quite a lot of changes there. Okay.
So it's just like for sticky sessions and all that, right?
All right. So let's try and replace the kube-proxy. Maybe in 10 minutes, because my concern is I'm going to just kill my cluster and then we're done. So let's try. What about, I seen something else in here, right? So there was something about DNS.
Yeah, so you could get DNS visibility as well. We can try this one, definitely.
So this allows us to document lockdown external access with DNS-based policies. So the DNS-based policies sound
right.
cool.
Yeah, so there are a few things. One option is that to sort of get DNS visibility, so you can see what is going on in cluster DNS, but you could also lock down access to some domains, for example.
Okay.
This is something to try, definitely.
And I don't need to enable anything, right? This is going to work with the vanilla install. Okay. So I am going and I just YOLO this. I'm just going to copy it. Feeling pretty brave now. Things are working.
Oh no, okay, good. Yeah. You missed API version.
Let me just let's just append it in here.
Sure, yeah.
So this is a FQDN network policy, very similar to this network policy of it.
Yeah, you now Cilium API version. Yep. Have a look at the page where you copied this from, in case this is like V1. Oh, it's also V2. Okay, great.
Now, so it's also using the same labels, which is cool. So this is still an org empire, except now we've got some sort of media bot, and this policy is going to allow traffic to api.twitter.com for kubeDNS. Okay.
Yeah.
Let's apply it. Still feeling brave.
Yeah.
All right. Now what that means is I can run, get CMP, I can describe FQDN, and in theory, Hubble should now be aware of our new policy. It is.
Yeah.
Okay. Now, let's see. So this.
Yeah. Let's go back to the document for a sec.
See, I'm trying to make my own destiny path here, and you're trying to get me to follow the docs. So I'll listen to
Well,
you.
that's what I do, David, as well. I'm just trying to
All right.
make
So
sure that we don't end up doing something odd again.
what is okay? That's
Okay,
applying the policy which we did. Okay, so now it wants me to use MediaBot and try and curl this API. Did we deploy? Was MediaBot deployed automatically for us? I don't know if I remember seeing.
No, I
MediaBot.
didn't see the media bot anywhere. Yeah, I think we need to find it.
Okay, so where was the apply for MediaBot? Oh, there we go. Okay. And I'll just change that version in case that's important.
I guess, yeah, 1.8.
8.5.
You just 1.8. Or, oh, well, 8.5 works too. Of course, it's a tag a brand.
So now we have the MediaBot, and we're going to try and exec a curl request inside of it and see if we can. Okay, so it's got a few URLs here. Let's try. I'm going to time it out.
So all of those events are not except for
API dot, right?
There you go. Sweet. It worked.
Okay, so I guess this wasn't an L7 rule. This is not Envoy blocking this, right? This is the pod is not able to resolve that host name. Is that right?
Yeah,
So,
I actually don't know that much about the implementation details of the PDM policies.
All right, let's have some fun. Let's see. Do we have bash? We do. So do we have dig? No. Do we have apt? No. Do we have apk? There we go. Add update DNS utils. I can never remember the name of that package.
How did? Yeah, I remember that it didn't exist.
Oh, so I've just
back in the day you couldn't get dig on Alpine just easily.
Well, right now it can't even resolve this.
Oh.
So let's fix that first. This is fun. All right.
Yeah, you can add Alpine CDN to that.
So we can just add a new match name. So let's allow it to do that. Drop it out.
Yeah.
And then let's see if that works. Okay, cool.
David, I worry that in Alpine you don't have this package.
Alpine dig command.
I think you'll find that. Oh, dig. Oh, there's dig. Okay, easy. You see, unlike the other distros.
No, it lied to me. Okay. Oh, bind dash tools. Okay.
Okay.
I wish it was just like there's just some tools I need to be consistent across distributions, like Ubuntu, Red Hat, Alpine. I just want dig, bind, DNS utils. Just standardize it. Be rude. All right, so that means that resolved. Oh, that wouldn't resolve anyway. That was just me being really silly. Oh, that resolved too.
Okay, so actually we.
Oh wait, because I'm not using cluster DNS. Maybe no, I am. Okay.
Yeah. Oh no, I think, but they try and curl that. I think what it actually comes down to is that it blocks it a layer below. It just takes the DNS into account.
Ah, right. Okay. Now, do we have visibility into its Hubble as well? Okay. Yeah, we can see this.
Yeah.
I like that it shows you that this is outside of your cluster as well.
Yeah.
Which is nice. Okay.
Yeah.
Let's see. What do we see in here then for those requests?
At the top. Yeah. So like you can see that, like for example, that one been dropped.
I'm not seeing the DNS lookup at all, though, right? Is that expected?
Right. I guess.
No, I'm just throwing loads of stuff at you. Like, explain this. Why doesn't this work? Like,
yeah. So you might want to have a look at.
yeah, this is only HTTP traffic, I think, right? We're not seeing non-HTTP traffic here.
Well, no, it's not that it's HTTP. I think you should see UDP here as well. Maybe this is showing. Could you look at, for example, the system namespace, kube system namespace? Yeah, I think actually DNS visibility was a separate feature that had to be enabled.
It's not important. I don't want to. I'm just enjoying exploring the network through this Hubble UI. Like, I'm sure there's other settings that probably need to be.
Yeah, that's right. But effectively, if you use a KDN policy, the enforcement is at the TCP level.
Okay, and then it's got an example where we actually combine these rules, so we can say, yeah, egress we're going to allow. Cool. And we can, okay, nice. Okay, that makes sense. Oh, so what does this?
Okay, so this looks like
that's port 53 on TCP or UDP. So right. I mean, there is something DNS wise going on here, and this rule is.
Yeah. So if you have a look up above, let's have a look a little bit above. The document should explain.
All right. Okay.
What this is all about.
So what did we apply to the cluster then? Is this in my? Let's have a look.
Yeah, is that part of it? Yeah, okay, it is already. Yeah. To endpoint.
Oh, but we allow anything. Okay, so we're not actually restricting DNS here.
Right.
This is egress. Ah.
Yeah. So you're just allowing traffic to kube DNS.
Okay, so we do allow all 53 DNS lookups. It's the egress that is being restricted to certain domains.
Yeah.
So I'm assuming if I change this pattern.
Oh yes.
And say we're only allowed to resolve star.twitter.com. And then let's reapply.
You know what the Alpine packages there.
So I should be able to do.
Yeah, and
that's actually right because the star wouldn't have allowed. So now that's really cool.
Try www or something that.
Yeah, so that should work, but Google should fail, right? It doesn't resolve. There.
Yeah, and Alpine should fail too.
Oh yeah, I've not got much hope for that running anymore. Yeah, it's gone. It's gone.
Okay, let's have a look at Hubble now.
Let's try. No, I don't think it's. There must be something we need to enable on the Hubble side. I'm assuming for the.
I think so. Yeah, I think there's DNS visibility tutorial that.
So it does have this, like the example filter here does kind of suggest that I can filter on DNS.
Yeah, because you could do that for the in the destination column the DNS names there. So.
Oh, there we go.
Oh, there you go. Okay. So
it's probably going. You
cross namespace traffic, right? Yeah.
Okay. You don't want to show DNS lookups by default because you're probably going to get a lot of that in a real cluster. So I'm glad I clicked that button randomly. All right, so let's see what we. Yeah, so here's a DNS lookup. It was dropped, and we were trying to look up something. Another one. Yes, I don't know if we're going to get the name of what it's trying to look up, but I'm sure that's something I'm doing. In fact, not here.
Yeah.
There's forwarded. I'm going to run it again. Hold on. Let's try that. What do we get here? Update. Oh, I don't know. Okay. Just keep clicking on stuff.
Definitely see DNS queries here and
all the Hubble stuff. All right. No worries. That's a really cool feature. I'm really glad we persisted with that and got to see that working. That was nice.
Great. You found it. I didn't know that.
So yeah. Okay. So I like that DNS-based policies. That's a really cool selling point as well.
Yeah.
You know, especially when we're trying to secure these clusters and stuff like that. You know, if they can't even resolve, like if we provide a wait list of things or a allow list that we allow to be resolved in our cluster, that's pretty sweet. Okay. All right. Now that we've got this confidence, because we're obviously just owning this now, we're going to do the kube-proxy replacement.
I'm sure it's going to work. Yeah.
Okay, so, I mean, there's other stuff we can do here. I mean, there's a lot of really cool things like securing gRPC and, you know, Cassandra and Elasticsearch, but I really just want to start messing with this kube-proxy now. So,
yeah, that's Kafka as well.
So let's search for kube-proxy, Kubernetes without kube-proxy. Let's make this work. So we are not going to kill kube-proxy daemon set yet. Let's see if we can get. Let's see what we need to do. So I can tweak the Helm command.
So you could do that, and I think there's well, you could have a look at the Helm chart source code and see what the values are for this to set in the config map. In fact, if you go and try and edit the Cilium config map now, let's do that. You've already edited it earlier.
Yeah, I'll work out how to get that back into the just file when I push this code online, but we can just do it direct for now. So this wants us to
kube-proxy replacement. Have a look at that. May be already set. Yeah, probe. Try and set it to strict.
Okay, and then do we need to provide the service host and service port?
Yeah, that's right. So because normally we connect to the API server using the using the service IP that kube-proxy provides. But since we're about to kill kube-proxy, we're not going to have a service IP in the first place. So yeah, that's the one that we'd want to tweak now. Is this here in the config map or?
Okay, so
have a look at API, for example. I think it's probably not in this config map. So let's have a look at the let's have a look at the Cilium chart. So if you go to the Cilium repo,
I mean, I can just rerun this. I've already.
Oh yeah, but we are in. Well, you'd want to. Oh yeah.
Yeah, because this is the Helm template, right? So I can just add these parameters.
Oh, okay.
And we can just regenerate it and reapply it.
You're not passing it through Pulumi or whatever, right?
No. This is just.
And you also want to change this for 1.9. So if you switch the docs to 1.8.
Yep. Okay, so let's see. Does that change?
Yeah. Global.
Okay. All right. So.
And you want the Hubble port back as well?
Yeah, let's do that so that I don't forget. So
if you go to
Cilium.
Yeah.
And then deploy folder. I already had to fight with this last week.
Install Kubernetes.
Install, and then Oh, look, GitHub have changed that annoying thing.
Right there, past it. It's good, past it.
I know. I was just celebrating that it's not hiding the folders anymore. That was like the worst change GitHub made in a while. Anyway, so
and change to 1.8 as well.
Yep.
1.8, V1.8. So I know 1.8 file should have been tagged. Yeah.
no values. Let's.
Charts. Oh, values as well. Yeah.
We want to listen a 4244.
Yeah.
So that's global Hubble listen address.
Not just, is it global Hubble? Oh yeah, it's global Hubble. Okay. So yeah, we got rid of those global values in.
Okay, so now we need to work out the Kubernetes service host and server support. How do I get those values? Does it tell me?
So you could get those from your kubeconfig file.
Yeah. Right. Okay. Gotcha.
If you know what's the private address, that's probably preferred, but
so it's this?
probably fine. Yeah.
Okay. Nope, wrong file. So we want this. 6443.
The IP address.
6443.
Yeah. Oh, service host and service. Yeah, I think so. Yeah. Okay. Well, I think this is just take a look at the docs once again, and
so are we sure that it's not just the actual service address?
Well, yeah, because
I need to do the right namespace.
Let's have a quick look at the docs just to refresh, because naming is not a trivial problem, as we all know. Replace API server IP. Yeah, no, because the actual, you see, it's just the API server IP and API server port.
Usually 6443. Okay, yeah, we've got the right values then. Okay, nice. So that means
naming.
so we don't need to edit that config map anymore. I can save this file, and we want to regenerate. So just what did I call it? Cilium. This regenerates our Helm thing. What did I get wrong? Slash.
Nice error method.
All right. So now I can reapply.
Yeah.
And Cilium. Oh, my spelling, my typing. And Cilium. Most of that will be unchanged. The operator has been updated. We may need to kick a few things, I guess.
Yeah. Delete. You had the delete command.
No, it's already restarted. Okay.
The operators. Oh yeah, and also the agent. Good. Okay. So we can have a look at the.
So is that it?
Yeah, right.
Can I go kill kube-proxy?
Kube-proxy, yes.
Let's try and get daemon sets, all namespaces, kube-proxy. All right. So delete and kube system daemon set kube. Now are we confident?
Yeah.
Done.
Could possibly go wrong.
So now we have no kube-proxy on any of our nodes, which means if Cilium is not working as we expect, we have no networking. So let's see if Hubble is still alive. It is. Let's try. And our ship still landed. Let's try the Twitter. The network is still good.
Well, check if kube-proxy is still kicking around. Maybe it's like still terminating.
Okay, so let's run get pods, kube system. It's gone.
It's gone. Oh my god. That was really quick and painless. That actually worked. David, how did we not screw it up?
So that means there's no. There will still be IT tables on our nodes.
No, do you want to have a look if there are any IP tables rules? Yeah.
Yeah, let's
jump into a node and have a look.
Yeah. Yeah, I can just get IP addresses from here. Yeah, let's go on a control plane node. In fact, let's
You
go
can
on
like
one of the worker
reboot
nodes.
it as well.
Okay, IP tables.
Yeah, IP table save. I mean, these look empty to me.
Well, there was something in the docs, wasn't there?
Yeah, let's have a good look there.
So done. Validate the setup. All right.
Oh yeah,
Let's do what it tells us. All right. Let's not celebrate too quickly. So
yeah, right.
so let's see what that's. Is
Give
that
it
just
the right
that?
font.
Oh no, the pod name's different. Of course.
Any of them? Shouldn't tab work?
Oh, different namespace.
Cilium
That's why.
namespace. Okay.
There we go. So yeah, we've got strict enabled on a kube-proxy replacement. We don't need an Nginx. We've already got enough things going on, I guess.
Yeah, no, we can definitely tell that this is. So you could do Cilium service list.
I'll just type it rather than changing those bits. Service server service list.
Cool.
Yeah,
That's good.
I see numbers.
Yeah.
Oh,
I
so
table save. Okay, let's try that. Yeah.
so it wants me to do that.
You can run that in Cilium pod, I think, or on the node if you still have a SSH session somewhere. Oh, still
So
looking
that should be
around.
empty. Clear IP tables.
Oh, just reboot the node.
But that will take 5 minutes.
Bare metal, I forgot.
How to delete and clear? Whoa.
You can try Firecracker. That's how quick node reboot. And immutable upgrades and such things. I remember sort of thinking about the design where you would use bare metal and single VM per host with essentially something like Firecracker, just so that you could get upgrades by means of images and faster reboot.
Okay, so I've now deleted all inputs, forwards, and outputs on this node.
IP table save was the one that we tried, right?
So now I'll just do it on all the nodes. I think maybe that's going to be quicker. So let's do this one. Copy this again. Oh. My finger is my SSH key now. So alright, gone. Last one. And that means that our worker nodes are all IP tables lists. So then we can test our traffic.
Yeah.
All right, so now we have no IP table rules on any of those nodes. So let's go back to the TIE Fighter. That still worked. Let's try Twitter. It works.
Oh, cool. Yeah, that's
nice. Yeah. Very cool. I mean, the only challenging bit there was just removing kube-proxy. It wasn't quite as trivial, I guess. But you're right. I could just have rebooted those nodes. That would have been...
Yeah.
That would have taken longer. So
I wonder why they didn't do tables rules set around. Not sure.
Awesome. That was really cool.
Okay.
Yeah. Let's pop that away. So, yeah, I'm really I'm impressed. Like, you know, I knew that Cilium did network policies. I know there's the eBPF, right? And that's one of the hottest things going on right now as far as kernel security and networking, because of the just raw performance numbers. So, Cilium and that integration is just really fast. Removing IP tables, that is really cool. I now need to go and upgrade some production clusters. And then the cherry on the top of that was those DNS rules. I didn't know that was possible. I just caught that in the docs and was like, that's a really nice feature.
Cool. Yeah, there's more various things that one can enable as well. I think IP tables is definitely something that we should be able to part with in the cloud native age.
Yes, definitely. I completely agree with that. Well, thank you for joining me again. We didn't break anything. Things worked. I think we explored, a lot of the high level concepts of Cilium. Hopefully, piqued at people's interest in it. Congratulations on raising money. Enterprise product, very, very cool. And hopefully, we can do some more exploration of Cilium and the new features at a future date. But that was great, Ilya. Thank you again for joining me.
Thanks, David.
All right, you have a great day, and I will speak to you soon.
You too.
Thanks.
Bye. Thanks.